Awesome. All right. Welcome back to day 14 of Foundations of Programming. Yesterday we finished off with SAT data. The last hour was really just you guys working individually and me bouncing around between rooms. Uh, I believe most of us were able to finish it by the end of it. Some of us stayed back a little bit later. We talked about it, and for the most part, I think everyone should have a completed SAT data. So for the sake of a recording and to ensure we have a demonstration for other people to see, because other people have been watching these videos, can I get a volunteer so you can demonstrate the final product of our code? Anybody?
I got it.
Nick, always on it. I want to hear Michael or Dominic be like, "Yeah, I got it, Roger." All
I
right,
just, okay. Let me know when y'all can see my screen.
we see it.
Okay. So let's pull up this. Okay, so you want to see the code first?
Yeah. Let's see the code first.
Walkthrough. Okay, so I imported JSON because we're gonna be working with JSON data. I made a class called sat data per the README. Actually, let's open that up too. Uh, an init method that reads the file and stores it in whatever data member you prefer. They must be private. So, like you said, I didn't even know you could put this code inside init because I'd never done it before. So I just kind of ran with it and it worked. I opened the JSON file, load the data, and I set that as a data member in the init method. And then I did hard code the headers. I was tempted to run another open and pull the first line out of the headers, but I just hard coded it because it said you could. Um, then you had to make a method called save as CSV that takes as a parameter a list of DBNs and saves a CSV file that looks like not that looks like this looks like this one. So it needed to be in this format. Got it. Row one is these headers, and then the other rows were going to be rows of this pulled by DBN. Um, this was just for a troubleshooting function that I wrote, the get data, because as I was going through, I was making sure things were printing out as it was supposed to. Okay, here's the save as CSV program. So it takes as a parameter DBN list, and that's a list of DBNs. So here's the test one I did down here. It's the one shown inside the README, except for I added one or two that included a comma or something like that. Yeah, it's this one, copy and pasted plus added one or two extras. So after messing with it for a while, I determined that how I was going to do it was I was just going to make a string that I was going to return or write to the file eventually, and I was every time I found information that needed to be in it, I was just going to append it. So the string is equal to self.headers. So the first information in the string is the headers. It sorts the DBN list because one of the requirements was it wanted, let's see, where was it? It wanted it sorted by DBN. So in
Right.
ascending order. Yeah, here we go. The rows in the CSV file must be sorted in ascending order. So I used this function. This line right here does that. It takes the DBN list and just sorts them. So even if you didn't input them down here properly, it sorts them. Now for the meat of the function. So for each DBN in DBN list, for each entry in self, oh, I did end up using it in here, self.getData. So after I looked around in the JSON for a while, actually, I just control F'd one of the DBN numbers. I think it maybe have been the first one. Found it right there. And so then sure enough, that was the DBN, and then it was followed with the other information needed inside the output CSV right there. It's in self.getData in the data uh, dictionary or the key of the dictionary. And then I said if the DBN is in the entry, so that if the out of all the DBNs inside the original JSON file, if it's in the uh, DBN list. Oh, one more thing I did was if there's a comma in the entry, this is the code that takes care of putting double quotes around it. And that actually took me longer than it should have. But if there's a comment in it, it adds double quotes to it and adds a new line to the end of the string. And then for this is something I learned in Python a while back. For IE in enumerate, the elements of this list from the eighth element to the end, which is this right here and this right here. If E is equal to none, then I changed E to be a blank string. That way, instead of getting in, for example, line 3, you would have got a bunch of nuns in here. It would have said none, so on and so forth. Or at least that's what I was getting. And so what I did is I made it to where it changes it to a blank string, because that's what it looked like it wanted in the instructions. If I is equal to 5, outstring. Oh, okay, so if the index in my enumeration up here is equal to 5, the output string gets appended the string of E. Else, output string, it appends string E and then a comma. And then so what that does is that builds the entire string, starting with the headers, then with the rows and commas. And then I used open to write to the out file. And the end result is this output CSV.
Okay. Yeah. Right on. That was pretty good actually. Um, yeah, I got no comments. It was kind of exactly what I really expected. I think other people would use a list, but string works just as fine too. So good stuff. I appreciate your demonstration. Thank you, Nick. All right. Does anybody have any questions about the assignment for SAT data? All right. Well, as I mentioned before, outside of the recording, um, unfortunately, I did tell you guys to do an assignment before doing an assignment that came before it, which is supposed to be noble data. So we are going to start today by taking care of noble data. Let's see real quick. Opening up on code. All right. Battle game. And we are looking at lesson 11, noble data. Here we go. All right, so for noble data, we're going to require JSON as well. We're going to write another class named noble data that's going to read a JSON file, right? It's going to allow the user to search that data. So this is going to be our JSON file, right? Our init method should be able to read that file and store it in whatever data member that we prefer, just like we did in SAT data. And then we also have to make sure they're private. And then we should have a method, right? A method, not a function, a method, which is going to tell you that it should belong to the class. A method named search noble that takes as a parameter a year and a category. It's going to return a sorted list in normal English dictionary order of the surnames for the winners in that category for that year, right? Up to 3 people can share the prize. The year will be a string, 1975, not a number, right? So the parameter, when you pass it in, the year that you take in as an argument should be a string, not a number. The categories are chemistry, economics, literature, peace, physics, and medicine. And here we have a quick code example, and it should be fairly similar to how SAT data was structured, right? You have the instantiation of an object that should run the init method immediately. That's going to read through this file and grab the data. And then you have the actual method itself that's going to do the functionality of grabbing one specific or, a unique item from here, right? Here is your JSON, right? We see prizes, and then we have, for example, year 2022. It tells you the category, and then it tells you laureates, which I believe it's like their term for pretty much saying like, oh, like people who won it, right? We have Caroline, Bertozzi, Morton Meldal, and Barry Sharpless. These are the three people that earned an award for chemistry. And then it goes still in year 2022. This time category is economics, and then so on and so forth. So it can have up to three, but you might also get one or two. So keep that in mind. So as you can see, it's significantly easier than SAT data, right? You just have to kind of parse this JSON data and then grab some of this. You don't have to work with CSV files here. So this one should be a little bit easier. So we'll take 30 minutes on this one, maybe, maybe less, depending on the progress that I see in the rooms. Um, but yeah, pretty straightforward. Do I have any questions? You're literally just taking an argument for a year and a category, and then you're finding the people that it belongs to, right? Nothing crazy, no crazy formatting requiring like we did with the CSV. This one, if you were able to complete the last one that we just did, this should be cakewalk. All right. I'm gonna go ahead and pause the recording, and I'm going to. All right. So Noble Data. We're going to write a class named Noble Data. This requires the constructor, which is the init method, and it doesn't say anything about any arguments, right? No parameters, nothing like that. So by default, it should just automatically know what file it's going to open. And because we're working with JSON, we're going to have to import JSON so we can leverage the load function. So with that in mind, we can say with open, and the file we're trying to open is nobles JSON. So nobles.json, and I want to read this file as in file. Can you guys hear my kid yell in the background? All right,
No.
good.
I do have a question though.
Yes.
Import, what would happen if you put that inside the class? Makes no difference, breaks, bad
That's a
practice.
that's a good question. I'm
Because then it would
not
only
quite
import it
sure.
when you run it, right? The class.
In theory, I guess so. I don't know. Try it out. But
I'll
that's a
play with
good
it and see if I can
question.
break it.
But normally your import should be at the top of your file, right? You wouldn't want to do it in a class, because when people read your code, stuff like imports, constants should be at the very top of your file, so they're easily referenced, right? So you know what's being used in this document. I don't know if it'll work. I can see it working, but it's just you wouldn't want to put your import anywhere else besides the top, even if you don't use it until like 200 lines down below. All your imports should be at the very top. Make sense?
Yes.
So we're going to import it, and then we are going to say, oh Lord, I haven't done this right in a long time. We're going to say data is equal to JSON.load, and I'm going to load it in file. Self.data. Did I do this correctly? I don't know this off my top of my head. I don't do this often. We'll say noble data is equal to noble data. Uh, print self.data. Let's make sure we got this right. ls python noble data.py has no attribute. What are you talking about, Willis? Line 8. Oh, self.data is equal to data. My bad. There it is. Good. Good stuff. Good stuff. Cool. Cool. Clear it up. So we have that there. Our data is in here. Let's look at the JSON file. Okay, we'll have it here. We have the limit taken care of. It is a private data member. All right, let's go ahead and remove this print statement. Now let's actually work with the method. We're going to say define search noble. And as we see here, it's going to take as a parameter a year in a category. So it's a year, comma, category. Now this should return a sorted list in normal English dictionary order. So I'm going to want to essentially iterate through all of the JSON data, and then look for a specific year, and then I'm going to look for the category. So let's kind of look through here. We see prices. I haven't seen this in a long time, so let me just scroll down and see if there's any other keys. Nah. Okay, so it should just be immediately prices, which now that I think about it, I don't really need to use prices. I'm just gonna go ahead and assign the value of prices as my data, so I don't have to keep nested into this key. Now this should just be a list of data saved in here. Okay. Well, in my function, I'm going to want to essentially iterate through this list because this is going to be a list of objects. The first object here will give me, where's the end? Right here, I believe. So it's a list of objects, and the objects has a key of year, category, and Loretz, but the Loretz is what has a value, which is a list of other objects. So I'm going to want to loop through this list. So I'm going to say for, let's see, I guess year, right? Because one object is a whole year. No, it's not even that. It's year. We'll say for record. For record in self.data. I'll just try and pick a good naming convention for this. We should grab one record, which should return the first record be year 2022, and it's chemistry. And the next record is year 2022, economics. As we get a record, we want to make sure if it's the year that we're looking for before we even start looking at the category. So we'll say if record year is equal to our argument year, then we're going to actually check the category, or we can actually kind of chain it here too. If year is equal to year and category is equal to category. All right, we can check both of these at the exact same time. Each time we grab a record before we even look at the prizes, I believe. I think I'm doing this right. Once we grab that, let me just double check this. We're going to search for a Nobel Prize that takes using the parameter Unicode returns a sorted list in normal English dictionary of the surnames for the winners in that category for that year. Okay, yeah, I think we're on the right track here. We should just be able to return all of Loretz because Loretz is going to have a list of the awardees. We'll say all awardees is equal to record Loretz, which will return to me a list of the awardees and assign it to all awardees. Now I'm gonna come out of this for loop because I have to iterate through these as well. And I do not want to do a nested loop so I can keep my the optimization of my code as best as possible. It's okay if I do two loops. It's just not nested that you want to avoid. So once we have a list of the objects, we're going to say for awardee in all awardees, which will hand me an object from each list at a time. I'm going to grab the surname for each award. So let's go ahead and create a list of surnames as an empty list. As I grab the awardee, I'm going to say list of surnames dot append awardee surname. Would you give me Bertossi, Meldel, and Sharpless if I was grabbing this one? And then I can say list of surnames dot sort, and then return list of surnames. Let's see if this is right. Do we have an example here? Actually, let's do this first one here to make sure we're getting something. And we're going to do print and the dot search noble. And let's run this. Python noble data.py. Basic to require, oops, my bad. It should be 2022 and chemistry. Gives me Bertossi, Meldel, and Sharpless. Exactly how I expected, actually. Let's see. The year will be string, not a number of the categories, chemistry, economics, returns a sorted list in normal English dictionary order of the surnames for the winner. Yeah, I think that's it. Did you get the same thing, Nick?
Hold on, 2022 chemistry. I did 2022 economics. Let me do chemistry and see if I get the same
I can
thing.
do economics. Oh, I got it. Boom. Let's see it. I got Bernanke, Diamond,
Bernanke?
and yeah,
Yep,
Bernanke. Yeah. All right, there you go.
in
Do I have
Bernanke.
it? Do I have any questions, Daniel, Michael, Dominic?
No question from me, but you helped me on, oh, let me look at your screen. Line 13 and 14, like that whole area of how to compare, how to grab the year and category.
Okay.
That's where I was struggling. So thanks for the explanation.
Yeah, no
I need to
problem.
learn how to spell.
That's okay.
I'm just gonna start copying and pasting out of the JSON and just put it in there.
Yeah, I got some fat fingers, so sometimes I'd be typing the wrong thing too. Over there, go. Sorry, my dog is trying to lick my hand. Okay, awesome. Now I know we're about to go on break. So what we are going to do, I'm going to pause the recording now. Who knows what a virtual environment is?
It's an environment where we can set certain parameters and run the code on that certain set of parameters.
Close. Very close. I thought Nick was going to say something, to be honest. Nick's usually on it. But not exactly, Daniel, but you're on the right track, right? So you guys actually installed it on during the install fest. I don't know if you guys remember, but essentially, I want you to think of the state of your computer right now. You guys probably have a bunch of stuff installed, right? You have probably Steam, Discord, whatever random stuff you guys might have. You might have installed different software throughout your time with your computer. You might have, if you've dabbled in code before, you probably have JavaScript. I'm sorry, not JavaScript, Java, C Sharp, maybe even Python installed. You have these versions of different software and different stuff installed, right? Um, what a virtual environment does, it creates almost like a pocket somewhere in your computer that is like a clean slate of a replica of your computer environment, right? Where you don't have anything installed. It's almost like a sandbox, like it's an empty whiteboard. Think of it, right? Where you can install programs that aren't directly installed into your computer, but only exist within this little environment. Realistically, it's actually just a directory, it's a folder, uh, where you're putting everything inside of. What that does, it keeps your installations from interacting with stuff that already exists on your computer or stuff from your computer interacting with anything that exists in this virtual environment. And a good way of explaining that would be, let's say Michael creates an application today right? And his application is written in Python version, I don't know what version we're on. Let's say 3.1, right? He has this website that he coded in Python 3.1, right? Um, and then later on, a year or two later, 2 years later, Python has updates. They go through like 6 different versions, right? And then he tries to run his his program again, but what happens is his entire program is written in a version of Python that is no longer used, right? The Python version he has on his computer now, since he's been running his updates, is probably like 4.8 or something crazy, right? So when he tries to run his website on his computer, it doesn't work, and it's because whatever Python version you have no longer uh, supports some of the stuff or functionality that you might have written into your website, right? And then that can be complicated. Um, so how do you deal with that? So that's where virtual environments come into play. And in a virtual environment, you can install a specific version of whatever code or whatever software, whatever dependencies you might have. You can create a program that is written in this version of Python or this version of whatever framework you're using. And then when you want to run this program, all you have to do is turn on the virtual environment and it utilizes the installations that are inside of this virtual environment to run. And it won't use what you have on your computer. Does that make sense? Right. So it's a way to create almost like a little whiteboard where we can install different things without it affecting our actual computer. So we're going to be using a virtual environment today so we can install Pygame. And the reason for that is because Pygame is what we're going to be using to create our Space Invaders games. I don't know if you guys seen it in the calendar, but we're going to be recreating the Space Invaders, or I think it's called Galaga was the actual name for the game. It's an old retro style game, right? It's like the spaceship, and then there's like asteroids flying in or aliens, and you're shooting them, and they're like coming down to your screen, right? It's one of the old arcade games. We're going to be recreating that today using Python, object-oriented programming, but we're going to be taking advantage of one of the libraries that come with Python that we can install. But Pygame, it doesn't get as much love as other stuff because not that it's not that useful in the real world realistically. Um, so it doesn't get as updated as frequently, right? I think the last update was like 2 years ago, a year or 2 years ago. Um, and the most latest version of Python sometimes might act weird, or certain versions might act weird a bit. You might have a different version on your computer. I know my other laptop had a different version, so it definitely wouldn't run it. Give me a second. My kid's in here. All right, so um, yeah, so we're going to be installing Pygame, but um, I also don't want it to be make sure it's not installed into your regular computer. So we're going to be using a virtual environment, and also it's good practice because you're going to be using a virtual environment for the most part through the entirety of the immersive program. So it's good practice to learn how to use it now. So the virtual environment module was already installed when you guys uh, ran through the installation for the install fest. So what you're going to do is you're going to open up your terminal, and ideally, there's two ways of doing this. The method that I'm gonna show you is the recommended method because it makes sure everything is neatly organized in your computer. But there's two ways of doing it. You could do one, the method I don't recommend, which is just create the virtual environment in the location of where your project is at. You definitely could do that, right? It's easily available. The reason why I don't recommend it is because as you're creating different projects or doing different assignments, you're going to keep creating virtual environments everywhere. You're going to forget what virtual environments you have, and they're going to be scattered through all your directories. So what I recommend is that you create a folder called ENVS, right? Like I have here. This should be at your root, right? Like the top level of your directory for where you start in your file path. You want to create a directory called ENVS. So for those of you, Michael, who don't have familiarity with the terminal, to create a directory in your terminal, you're going to use the command mkdir for make directory. And then you're going to type in the name of your folder and then press enter. Make sure you do this wherever your root's at. If you want to go back to your root, all you have to do is type in CD and then press enter, and it'll take you to the very top, right? Just CD. It'll by default take you to your root. And then here, that's where you want to run the command make directory and then envs. Now, to actually create a directory, I'm sorry, not a directory, to actually create a virtual environment, you have to call Python. If you don't have an alias on your computer, you have to use Python 3, obviously. I've seen a couple of you guys, I don't think some of you guys didn't set up the alias correctly. And that's okay, we can talk about it at a different time. For those of you that can't just run the command Python on its own, make sure you put that 3 at the end. So you'll say Python or Python 3 space -m, which stands for module, right? This is the abbreviation for module, right? You're telling Python, hey Python, I want you to run this module, right? Just the same way that when you guys run a file, you say Python and the name of the file. Here you're saying Python -m. Now, what module are you going to run? The module is called VENV, which is the abbreviation for virtual environment. After you run that, you're going to specify the name of your virtual environment, or in this case, you're going to specify the file path and then the name, right? So if you created a directory like I recommended for your virtual environment, you're going to start with a tilde, right? The tilde is going to represent your root, right? This lets the file path know that this is your root. So it should be tilde / and then the name of your envs directory. After you put that directory, you put / again, and here's where you're going to put the actual name of your environment. So I'm going to call this example-env. For you guys, I want you to write in pygame-env, because you are currently creating your Pygame virtual environment. Right, so for you, it should look something like pygame-env, right? Once you have that, I want you to press enter. It might take a second, but after you do that, I want you to type in ls and then the name of your envs directory so you can list out everything inside of it. And you should see your virtual environment in here. I have 3 that I created. One for tcanters when I was working earlier. I created my Pygame environment earlier as well. And here's my example env that I just created. Does anybody have any questions, or are we able to get this far? No issues?
I'm gonna have to probably restart my computer to get the whole hypervisor launch thing to work again, because my Ubuntu doesn't work.
Okay.
But I'll
We'll
just work on that.
we'll take care of that right now in a bit, because you're gonna have to do it for the assignment. So we'll take care of it right now once you go on break.
Okay.
So in that case, Michael, do not do everything else that we're about to do. But if you listed out your environments directory, the next step, which I want you to do, is I want you to go to where you want to set up your Pygame, right? For me, it's where I have the curriculum for FOP. So go to your FOP curriculum, and I want you to navigate to it and then open it up in VS Code using code and dots, right? So I want you to open up your directory there. If you don't have VS Code open like that, which we should all have had already. To be honest, I don't know why I made you open it up again. My bad. But after you open it up, what I want you to do is I want you to navigate to lesson 10, right? In your terminal on VS Code. So in VS Code, you're going to navigate to lesson 10. Your screen should look something similar to mine. You should have VS Code open. On your terminal, you should be at the location of where you're going to be working with Pygame. The Pygame lesson for us is going to be on lesson 10. Once you're here, we're going to activate our virtual environment. So we created it, but it's not activated. The way that you're going to activate it is by saying source, then you put space, and then you're going to look for the file path of your environment. So just like we did before with creating it, we're going to do tilde/envs/ and then the name of your environment, and don't press enter yet. It should be something like this, where you say source, space, and then the file path of where your virtual environment that you're about to open up is at. Once you get up to this point, you're going to say /bin/activate. It should look like this. Once you have it looking like this, you're going to press enter. And what should happen on the left side of your terminal, where it shows your user, you should see the environment that you created is now activated. If you see the environment name on the left side, that means your virtual environment is now activated. Do you have any questions? Everyone got this far?
Yes.
Okay.
If you were to leave the virtual environment or close it, would opening it be the same as you type source tilde file path to activate again?
You type in the command deactivate and then press enter, and that's it.
And to reactivate it, you would just do the line you did twice above. Yeah, okay.
Right. So realistically, the way you activate it is by source, the name of your virtual environment. So like pygame-env, bin, activate. What this is doing is actually running this file. These are files right here. This is a folder. Bin is a folder inside of your virtual environment. And then activate is a file. Let me see if I can show you where it's at.
Also, what is source?
I don't know off the top of my head. I'm not gonna lie to you.
Okay.
But here's my Ubuntu directory. Right here is those folders I had: Platoon, ENVS, personal projects. When I go to my ENVS, notice it's just a folder. Right here's my Pygame environment, and here is the bin folder that we specified in the file path, and here is the file that we're running, which is the activate file. This file is what runs the virtual environment. Right? So that's essentially what we're doing. We are running the virtual environment. That's a good question. I'll answer your question a bit, Nick, after a quick research, because I don't know off the top of my head, but that's a very good question. Now, what you can do, if you want to see what you have installed in your virtual environment, you want to type in the command pip list. And this will show everything that you have in your virtual environment installed. Right? So as you can see, I don't have anything crazy. I already have Pygame installed because I installed it earlier off camera. And we're about to go through that. So pip list will show you what your virtual environment has installed. You should only have pip. Do you guys have pip, or is it nothing?
Mine's pip, but it's a different version. Mine's
That's okay.
25.0.1.
Oh yeah, I just haven't updated mine in a while. That's not an issue. Don't worry about it. But yes, so you should have what dependencies you have installed. So if you install Python while your virtual environment is installed, you'll see what version of Python is installed here, right? So that's pretty much how this works. It's just like a little environment that your computer references so it can run programs. Now, the next step is to install Pygame. So Pygame, this is the documentation page for Pygame. It's called pygame.org. So I'm going to have you guys run this command right here. Python 3-m pip install. I'm gonna send it in the chats for Zoom. You want to run this command while your virtual environment is activated, right? That way it doesn't get installed into your actual computer. It's being installed in the virtual environment, right? So you just copy and paste that. Make sure that your virtual environment is already activated before you run the command. And then let me know if once you guys are ready.
I'm gonna go ahead and restart my computer now.
Okay, Michael, sounds good.
All right.
Yeah, I got it to install.
You have to what, Dominic?
I said I got it to install. Everything works fine.
All right, bet. Not just yet. We don't know that yet. This is going to be the test. So to make sure it works, what you're going to do, we're going to run this command here. And what this is, it is a demo. It's a demo game. Notice it's called pygame.examples.aliens. Pygame provides this for you. It automatically installs it when you install Pygame, so you can run it. It's a simple program to make sure that it's actually running properly. I'm going to drop it in the chat. You're going to type in, you're going to copy and paste this command. It should look something like this. So here I copy and pasted it. Then I'm press enter. And it's going to open up a page. Now I died immediately because I didn't move it, but you should be able to move and actually shoot. Right? I'm gonna drop this command and you should be able to have this open up for you guys. If it opens up and runs, that means it's good to go and we can move forward with the class. If it does not run for you, then we have to do some troubleshooting.
Yeah, it's not running on mine.
I knew yours wasn't gonna run, Daniel.
Why? Because I'm on Mac OS.
That's exactly why.
And this game's hard.
I'm not bashing you. It's usually the Mac OS that I have problems with when it comes to Pygame. I knew it wasn't gonna run. I should have stopped the moment I knew that you were on Mac OS. Let's see.
I mean, worst comes to worst, I can swap to my PC.
No. Were you able to install everything else with no issue?
So the Python 3, that pip install that you put in there, chat, it shot me an error as it was installing.
Okay, run this one. Run this next command that I just sent you.
All right. Command not found. Command tech M. Oh wait, it's because I didn't highlight it all. Let's see. Cannot perform a -- user install. User site packages are not visible in this virtual world or virtual environment.
Okay. Then exit out of your virtual environment. You might just have to install it without the virtual environment. Type in deactivate it and run it without the virtual environment.
Let's see. This environment is externally managed to install Python packages system-wide to approve. Install a Python library that isn't.
Is everyone else good besides Daniel and Michael?
Works for me.
Okay, Justin, are you good? Are you still AFK? He may be. Daniel, are you good? Daniel Bittner, I know you're there.
Yeah, I've been following along. I'm good.
Okay, right on. All right,
Yeah, now it's saying error externally managed environment.
the rest of you guys go on a 10-minute break. Come back at 7:07. Daniel and Michael, you guys have remedial with me. All right, let me go ahead and pause the recording. All right, welcome back. So we finished the installation for Pygame. Just to kind of go over the installation process real quick for anyone that's watching from home. What you want to do first is ensure the virtual environment is set up, which I believe I went through on camera. Is that correct? I did record that part. Okay, yeah. For the links for Pygame, you want to make sure that you grab them from the website. So you can just visit pygame.org, or just go to Google. Oh, that's GitHub. Google.com, and you can type in Pygame, and you should be able to go to Pygame News or Docs, really. Yeah, no, never mind. Don't go to Pygame News. Pygame.org/news is where you want to go at. You want to grab the latest installation for Pygame. So for Windows, the one that we ran was this one for all Windows users, right? We want to install the latest version. For Mac, it was a little bit more complicated for that. Right, for you Mac boys, I had to go to getting started, and there's a specific one that you run, which is right here. But the issue is with Homebrew, you require a virtual environment. So you have to run a virtual environment to make sure you can run pip install. But it's going to not work if you use user. So really, you just want to run this command for you Mac boys at home. Run this right here, and it should be working correctly. And then to ensure the program is actually properly installed in your computer, you want to run this code right here. That's going to run a default game that's already installed when you install Pygame onto your virtual environment. This will open up a quick window to just demonstrate that the program has been successfully installed. And that should be it, really. Let me give me a second. I need to finish setting up because I actually messed up my setup. Okay. Here. All right, so everyone should be with their VS Code open. Their terminal should be in the directory for lesson 10 of the curriculum. Your Pygame environment should be activated so you're able to use Pygame. And you should be here. You should have lesson 10 opened up here in your directories. You're not going to find too much here. You're going to find a folder called assets, and you're going to find a README. Realistically, this README here will actually have everything that you need. It's a little outdated, so really just follow the installation video throughout the recording to install Pygame. But if you want to follow through with some of the commands that I use, I kind of created a Pygame cheat sheet. I admit maybe it's not the best formatted. I kind of did this over like a weekend, this entire lesson, and I never went back and fixed it. Only because this program or this lesson specifically was temporary, right? This lesson for Pygame is an extra lesson that I implemented for a specific reason. So you can find the entire process from start to finish of everything that we're about to do here if you want to reference it. There might be some differences because I try to do everything in real time as I go through, so I won't be reading directly from here and copying exactly what's here. If you get lost and you have to reference something, you could definitely come through here and check it out. For any of the commands I'm going to be using, they're straight out of the documentation, and they're provided for you in the cheat sheet at the top. And I'll be covering these commands. You don't have to memorize anything today, and I'm going to explain why. All right. So let's go ahead. What I'm going to do here, and what you guys are going to be doing is going to be kind of following along with me, right? So what I want you guys to do is I want you to create a file in your lesson 10, and and to be called main.py. And of course, I butchered the naming. Main.py. And please bear with me because my keyboard seems to be acting up again. All right. This main.py is what's going to hold our entire game. Now, before we do get started, as I mentioned, this is an extracurricular lecture, right? And this lecture is going to be leveraging the Pygame module that Python provides, right? The Pygame module allows us to essentially create a game using Python. Now, if you guys are into game development or you're a little nerd like me, I do want to tell you that Python is not a coding language that you want to use to make games because they won't run effectively, right? This is for like small scale stuff, you know. Python, the coding language, is not very effective for managing games because of the memory performance. That's why we have languages like C#, C++ to handle that. So this is not a game development lecture. This is going to be an object-oriented programming lecture. So one of the things that I see really is that for new students, they struggle to visualize what classes and objects are doing, right? And it's because typically all we see is code. We see a bunch of words, letters on our page here, and some of us are a little bit more visual learners. So I concocted this little extracurricular lesson to provide to you guys to hopefully be able to visualize what your objects are. So when I say, instantiate an object, you can actually see an instantiated object come to life on your screen. So you are aware, oh, I'm actually creating an object and here it is visually, right? So we're going to be using objects to be able to create the different things in our game, like our spaceship, our aliens, bullet classes, and we're also going to be using classes to neatly format our code so it's not all over the place, right? We're also going to be leveraging inheritance like we talked about before. There are some other pillars to object-oriented programming, but because this is a foundations programming class, I'm not going to all the principles of object-oriented programming, just enough for you guys to kind of get your feet wet. You'll get more about this in the actual immersive program. There's a whole week on just nothing but object-oriented programming. But by the time you guys get there, you should be fairly confident on the basic stuff about object-oriented programming, where it should be easy to pick up. But we're going to be using classes to organize our code, format it in a way that we don't have to repeat ourselves. So we can just reuse the code that we are creating, right? Usually I get very good feedback about this class. There's the occasional like heavy hitter, like try hard student, and it's okay, who's like, I don't know why we learn Pygame because like we're not going to use an immersive program. Like that's fine. Like it's not you're not learning Pygame, and I say it from the start every single time. Disclaimer: we're not learning Pygame. We're just leveraging Pygame as a tool to help us better understand object-oriented programming, and so on and so forth. Which is why I give you all the commands, right? All the methods and functions. I'm going to give them to you, and you don't have to memorize all of them. I'll tell you what they're doing and why we're using them. What really you have to take away from this class is the same principles that we're using for object-oriented programming, how we're implementing it here in a different way that's been different than we've been doing for the last 2 weeks, right? So hopefully this kind of gives you a better understanding of how classes and objects work, right? Now, without further ado, let's go ahead and get into it. So just like HTML, right? When we created an HTML document, we had kind of like a boilerplate template. We needed a skeleton to run an HTML document, right? There are some basic stuff that we need in our HTML document to work. We had our doc type declaration at the very top that said doc type HTML. We had a head, we had a body, and we had it all wrapped around an HTML tag, right? That was like the bare bones of what your HTML document needed to work. We're going to need something like that to make sure we have a basic window, just a window here that's going to appear on our screen to work. Now, the way that we're going to do that is we are going to go ahead and we're going to initialize Pygame. So I say initialize and not import because we're not importing a module, it's installed. We installed it into our virtual environment. So to initialize it, we're going to use the Pygame command. I'm going to say dot init. And I'm seeing some issues here already. No, why is that? Hold on. Pause. All right, ignored everything I said. We're gonna import Pygame. All right. So at the very top, before we even use the Pygame init method, I guess we still have to import it even though we initialize it. Like quick disclaimer. I only use Pygame every time I teach this class because I use it as a tool. I don't know Pygame like fluid enough to just make awesome cool games. Like I said, it's a tool. I know basic methods, so I forgive me if I struggle with some of these methods, right? Pygame is not like an actual stack that we use for full stack software development. I'm just using it as a tool. So I might not remember all these commands from the top of my head. So we're gonna be referencing the documentation a lot. So just bear with me and we'll follow through and hopefully you have some fun. And then by the end of this, you have some kind of small game that you can have with your kids, you can play or just mess around with on the weekend. So do bear with me. But yeah, we're gonna go ahead and import Pygame. And now, there we go. We should have this working. Even though this is giving me some weird issue, we'll still move forward with it because it looks like it's recognizing the Pygame module, but this is for some reason squiggled out. I think it's still working because we can use this. This was really important here, right? But we're going to initialize the Pygame module, which is now going to allow us to use the methods. And the fact that I can use the init method is telling me that I should be able to use it, right? So we have that set up. The next step is going to be to set up a basic window. And the way that Pygame is going to create the window is going to be by calling Pygame. So Pygame dot display dot set mode, right? This is a method that Pygame module has. Think of it, all the methods that we're using, it's kind of how like the random module works. You know how they have like randint and different methods that come with random? That's kind of what we're doing here. These are the methods that are coming with the module, right? So we're going to use a set mode function here. And what this is going to do is going to take an argument. The first argument is going to be a tuple. And we're only going to need the first argument really. But that first argument is going to have to be a tuple. And this tuple is going to be the x and the y axis of what our window should be, right? For starters, I'm just going to set it to 500 by 500 using a comma, right? So this should be a tuple data structure. So it should be 500 by 500. Next, we are going to come down here. And then we are going to set up an event. Let's see. An event. How do we do this? All right, pause. I want this all to be in the class, so I'm already starting off wrong. We're going to create a class. We're going to say class game. And then we are going to define an init method. And this is going to go inside my init method. There we go. So everything stays the same, but we're going to put it all in a class so it stays formatted. The pygame.init and pygame.display will all be handled the moment that we run the game class. And now we need another core feature, which is going to be a clock. If you guys play games like Call of Duty or anything like that, you should probably be familiar with something called frame rates. Is that correct? Right, so we're going to have to create something like that to mimic how many frames per second our game is going to be able to track. Now, to do that, we need to create a clock variable. So we're going to say self.clock. And this comes from Pygame as well. the command is going to be pygame dot time dot clock. This method right here is going to create a clock in Pygame, and we're saving it to the variable called self.clock. And you can put it as a private data member if you want. We're not going to make anything private today to make it easier to go through the lesson. But what this clock's going to do is going to help us track our frame rate. Right? It essentially just starts a timer, right? You start a timer. Make sure your clock is capitalized C. Right? This is very basic. We're initializing Pygame. We're setting the window, and we are creating the clock to track the frame rate. That's all being handled within our init method. The next step is going to define our run function. So we're going to define run. And thinking back to the games that we've done, like the D&D game, I think we did guess a number too. We did tic-tac-toe, right? We use while methods to keep the game running. We're gonna do something fairly similar to that too, right? To keep this game operating. So we're gonna say while true. And this is gonna start our while loop. So whenever the game uses the run method, it should start running all the events happening in my game. Now, the way that games work, they essentially have events. Think of your HTML documents, right? Your web pages. You remember clicking on a button, you're able to listen to an event, right? The clicking of a button, the mouse up, the hovering over your mouse over something, that's an event, right? Games do something very similar to that, right? Pygame is able to track events, and this is how we're going to know when we click a key or when we move a mouse, right? So to grab the events of what's happening, very similar to how we use add event listener or listen to events, right? We're gonna do something like that. So to check the events, we're going to say if event.type, my bad, not event.type. We're going to say for event in pygame.event.get, right? So this command is grabbing all the events that Pygame is tracking, and we're going to loop through all the events. Right, and we can see right now, I'll show you a little bit how this event's working and what it's giving back to us. I want you to check here. As we loop through the events, we're going to check for one very important event right now, right? Because right now, all we're doing is setting the skeleton for a window. And the event we're going to be looking for is the quit event. So we're going to say if event.type is equal to pygame .quit in all caps, right? One of the events that Pygame tracks is if you quit the game or not, right? So we need to listen for this event. And if the event is equal to that, we're going to say pygame.quit. Notice that this is in lowercase. We're going to say pygame.quit, open and close parentheses, right? So we're going to run the method to quit. And then that should work. We might have to come back and do some fixing here. Sometimes what might happen is when you quit out of Pygame, it might not actually close your window. So if it doesn't do that, we'll come back and we'll manually close it, but this should work for now. All right, so every time that our game is running, we are constantly checking if the player quit or not. If he didn't quit, then we're going to keep going. It's almost like an if-else check. Like, remember yesterday's game where we checked if the player was still alive or the enemy was still alive? And if so, we continue playing. Something fairly similar to that. We're going to make sure that the player hasn't quit yet. And if so, we quit. So that's what that's going to do. Now, back outside of the for loop, right? But still within the while loop. So I want you to exit out of this for loop, but still stay within the while true. We're going to say pygame.display.update. So what this is doing is every single time our game iterates through this while loop, we're updating everything on our screen, right? Pygame is going to grab our display, which we already defined earlier, right? Here's the pygame.display. And we are going to run the update method on it. So it updates our screen, right? If we have a bullet and we shoot it, how do we make sure that our screen depicts as it moves? We need to update the new location of the bullet, right? If our character moves left or if our character moves right, we need to make sure our screen is able to update the new position for our player. And then for everything else, that's what this method is doing. We're just updating the new screen that we have. And then finally, we're going to say self.clock, right? We're calling the clock that we created earlier, .tick, and we're going to set it to 60. So we created the clock earlier, but now we're actually going to set it to a timer, which is going to be 60. This is setting our frame rate to 60 frames per second, which tends to be pretty average for most people, right? This is going to make sure that our game doesn't try to run faster frames than it should, which might hinder our performance, right? And that should be everything we need to get a basic window, right? Quick recap. We created all of this in a class of game. The moment we instantiate this game class, we're initializing pygame. We're setting the display window. We create our clock. All this is created once it's initialized. When we run the method, it's going to start running this infinite loop pretty much. That's constantly checking if we quit or we didn't. And it just updating our screen and it's capping our frame rate to 60. That's all we're doing right now. Right? There's nothing else happening. There's nothing on our screen. We're not tracking no mouses. It's just constantly opening up a window and just keeping it open. Now, with that in mind, we can say Space Invaders is equal to an object of game, right? We're going to instantiate our game object, and then I'm going to say Space Invaders dot run, and we're going to run our method here. Now, let's run this main.py, and we should have a basic black screen on our desktop. Is everyone up to this point?
Yes.
Right on. Okay. Good stuff. All right, I think we're good. I don't know what this error means. Okay, good stuff. We should all be good. Does everyone understand everything that we just did?
Just out of curiosity, can you explain the 500
Yeah,
on the display? Is that pixels or something?
actually it is, right? We're setting it up to 500 by 500 pixels, right? It's the height and the width of our screen, right? The left is going to be your x-axis and the right is going to be your y-axis. Does everyone understand how the x and y-axis works? If you don't, speak up now. All right. There's always some goober at home that doesn't understand it. So let's go ahead and cover it real quick. All right. So here's TeoDraw. Here's your window, right? This is your desktop, right? This is your screen. Now let's go ahead. Let's use red. All right. This is your y-axis. And this is going to be your x-axis. At this point right here, it is 0, 0, right? Coordinate 0, 0 at the top left of your screen. As you move to the right, oh, what the heck happened here? As you move to the right, the x-axis increases. Let's say your screen is 500 pixels wide. Over here, this will be 500 by 0, right? Because we're all the way to the right on the x-axis, but we have not moved on the y-axis. We've only went to the far right. Over here, this is 0 by 500, right? We went all the way down on our y-axis, but we did not move on our x-axis, right? The y-axis, as you go down, it's positive, and as you go up, it is negative. So over here, it's negative y. So keep that in mind. If I want to put a point like in the center, what would this be?
250, 250.
250, 250. Okay. If I want to put a point right here, take a quick guess. I know you're not going to be accurate.
250, 100.
250, maybe not 100, maybe like 50. 250 by like 50. Because if this is 500, 250 would be like right here, right? 200 will be like right here. So maybe like 50 or 100 will be probably closer. But that was a good guess. But yeah, so that's kind of how this works for all you goobers out here. All right. Let's go ahead and continue. So we have something very basic. We have a running window, right? When I run my function, it gives me this. Now, this is just something so we can get something started. I'm going to actually set this to 800 because this is too small of a screen. Yeah, and I encourage you guys to make either 800 or 1,000. You want to make it an even number because it's going to make it easier so we can like move stuff around our screen. It can get very complex once we start trying to center stuff or make it look nice and pretty. 1,000 might be a little too big for you guys if you working on a laptop. So maybe 800 is a better way to work it. Oh, not 1,000. So we'll keep it to 800, 800 for the example. So we got something working. That's cool. But there's nothing pretty here, right? There's nothing visually appealing. What we're going to do next is we're going to add a background to our game. Now, the background that we're going to use is going to be in our assets. You should have all the images we're going to use. We're going to use the outer space image, but we're going to have to load it into our game. Now, to load it into our game, we have to create a surface. Now, what do I mean by that? I want you to think of our window. Think of it as a 2D plane, right? You're looking at it from the side, like or like a table, right? When you look at a table from the side, right? This is all you see, right? You're not looking from the top. You're looking at from the side. So a table, you see the long ways, right? You don't know how deep it goes. Well, this is kind of how your table looks like, right? If you want to draw on something, Michael, what would you do? Would you draw on the table?
My kids might, but I would try not to.
Right. So what would you draw on?
A piece of paper.
Yeah, a piece of paper, right? You might want to have some kind of other surface that you can draw on. So you might have a piece of paper, you're going to lay it on top of your table. And then you're not going to draw directly on the table, but you're going to draw on this other surface here, right? This piece of paper. That's what we're about to create. We are going to create a surface that we're going to place on top of our display that we can draw our image on. Does everyone understand this concept? All right. So because we don't want to directly draw on our window, we're going to create a surface. And Pygame has a method for that. Now I'm going to make sure I separate my code, right? The first part of my init method, that's going to be all to initialize my window. So I'm going to go ahead and come down here. I'm going to add some a note here. This is going to be my background surface. All this is being set in my init method, by the way, right? The moment my game object is instantiated and the run method is showing me this, it's going to be immediately ran in the init method. I'm going to create a space surface, right? So we're going to call it, we're going to say self dot space surface. This is going to be where I'm going to draw my outer space image, right? This is my outer space image. This is what it's going to look like, right? I want to draw this image onto my space surface, but we have to create the surface first. So we're going to say self dot space surface is equal to, and to create a surface in Pygame, we're going to call Pygame dot surface with a capital S, and you're going to give it a dimension just like you did the window. So you need to know how big your canvas is going to be, your piece of paper, your surface, right? And because it's going to be my background for my entire game, I probably want to make it as big as my window. So what do you think my X and Y axis is going to be? 800,
800.
800, 800. Absolutely, Michael. Right, this is going to create my surface. Now, I created my surface, but as it stands right now, it does not show on my game, right? So we need to actually show that. So how do we do that? Well, in the run method, we're going to apply our surface. So between the for loop and before display.update and self.click, I want you to open up some space because this is where we're going to be doing all the actual drawing of our window. It has to be within the while loop, but make sure it's not within the for loop. This for loop is checking events. After we check an event, we're going to make sure we're drawing our stuff, right? To add it to our game, we need to put it onto our display. But I did a mistake here. And my mistake was I did not assign this to a data member. So I'm going to go ahead and update this. I'm going to say self.screen is equal to pygame.display. So that was my fault. I kind of skipped that step. We're going to create the display. We're going to save it to a data member so we can call on the screen and we can actually do something to the screen. All right. Any questions here? Cool. So now that I have my display actually saved into a data member, I can call this data member and do something with it. So down here, inside of the while loop, but make sure it's outside of the for loop, we're going to say self.screen is going to be, I think, what do we do? Oh, it's blit. We're going to say self.screen.blit. Blit is a method, which really, it's just a fancy word for saying, I want you to put something on top of me, right? Blit something on me. I don't know why they use that verbiage, but blit is just saying, put something on whoever is calling me, right? So screen is calling the blit method. So whatever is passed into the blit method is what's going to be put on top of the screen. So we're going to say self.screen.blit. And then the first argument we're going to pass in is what we want to add to the screen, right? So this is us putting our canvas on top of our table, our piece of paper on our table, or in this case, our surface onto our screen, right? So we're going to say self.space surface. All right, so I'm going to put my space surface on top of my screen. And the second argument is where do you want to align this in relationship to your screen? Well, the way that Pygame orients its objects is going to be by the top left corner of the object, right? So I want to align the top left corner of my surface to the top left corner of my screen. So what coordinate will I be using?
0, 0.
0, 0. Right, so it's going to be a tuple of 0, comma 0. So I am saying, hey, on this screen, I want you to blitz the space surface at coordinates 0, 0. So we have the space surface on our screen. But now that we have the surface on the screen, now we have to put the picture on the surface. Make sense so far? So with that same concept, we're going to say self dot space surface dot blitz. Right? The same way that we just added the space surface to the screen, we need to add the image to the surface. Now, because this is an image, right? It's not a data member. The first argument we're going to take is going to be Pygame dot image dot load. And I am going to load in my image here. The way you do that is by passing in the file path, right? Because my main.py is one level above the image, I have to go into assets and grab outer space. So I have to say assets / and then the name of my image, outer space.png. Right? Now, if this confuses you, you could do it just like you did the data member. You could come up here, create a data member like self.outer space image is equal to pygame.image.load. And you can load the image here and then just split the data member in here to keep you from being confused. And that helps you understand this. All right, the point is we have to load the image somewhere. Whether we load it and save it into a data member first, or we just load it right off the bat right here, it's up to you. So whichever one you prefer, it doesn't really matter. There's no right or wrong answer. If it helps you visualize this better by putting it into a data member, by all means. But I'll just keep it as is. Right, so here's my image for my first argument. My second argument, what do you think is going to be?
Is it the coordinates of where you're going to blit the image?
Correct. Just like we did earlier, we passed in what we're blitting and the coordinates. Here we're blitting the image and then the coordinates. And because I want my image to make sure it's the same size as my surface, which is the same size for my display, I'm going to do 0, 0. And now, that should be everything that we need to make sure that our image is displayed on our screen. Is everyone up to this point? Anybody confused? Dominic, you've been very quiet. You good, brother?
Yeah, I got all the same things.
Awesome. Good stuff. Good stuff. Daniel? Nick?
Yes, sir.
All right. Nick's like, I already finished the program. What are you talking about? What are you talking about? Awesome. So let's go ahead and continue. I'm getting an error here. Let me see if I can fix it. Import sys. Sys.quit. Stand by. What was the command? sys.exit. Okay, all right. So we keep getting an error here because it's not exiting correctly. So although we're quitting, it quit with an error. So what I did here is I'm making my Python file use the system to exit out manually. So if you want to keep avoid getting this error every time that you close the window, I want you to import sys for system, and then actively pygame.quit, call the sys.exit method. What that does, it manually closes out that window when you press that X button in the top right of that window screen. That'll keep you from getting an error message. You don't need it. It just bugs me to see that error message every time I close it up.
I have a quick like housekeeping question. I
Sure.
don't think it matters too much because it's working, but since we created the variable self.screen, do we want to change the update method down below to update the screen with self.screen or just leave it as pygame.display?
That's a good question.
I guess we could leave it. It's working. It's not a big deal. Just curious.
Self.screen got update. I think you. Yeah, don't ever recommend that again. I'm just kidding, Michael. Yeah, let's just keep it at pygame.display.
It's weird because the clock one works. That's why I was
Yeah, I
like,
know.
don't ever recommend that again. I'm just gonna mute my mic forever.
I'm just kidding. No, I appreciate that, Michael. That was a very good catch. I honestly, it made sense to me, which is why I tried it out. I don't know why it's working. Maybe it's just a pie game thing, but your logic makes absolute sense. I agree. If this is set there, you would think that it should work. Uh, but yeah, I don't know why it didn't do that. Pie game being pie game, it's okay. It's a small library, so it
Oh,
might not be the best.
is it because self.screen is like that whole thing by display set mode? So when you update, never mind.
Well, that's possible because the self.clock doesn't have any um inputs, doesn't have any arguments inside of it. Whereas the display one, the self.screen has arguments set inside of it, so maybe that's why.
Yeah.
Maybe. I don't know.
Whatever.
It's okay. Thanks for the recommendation though, Michael. I don't want to shut you down like that. It was I just thought it was funny. All right. So cool. We got our image working, right? So we got a nice window. It looks nice, but this is not the game, right? So we want something that's a little bit better. So let's go ahead and add our first character for our game, which is going to be our spaceship. All right. So for a spaceship, I like to practice what I preach. So let's go ahead and we're going to create a different file for this character so we can keep it away from all this extra mumbo jumbo so it doesn't get cluttered. So I want you guys to create a new file. And it's going to be spaceship.py. This is where we're going to define our main player. Right, we're going to want to use the pygame method. So we want to import pygame here too. And we are going to define a class called spaceship. For classes that have multiple words in them, you do want to use capitalization for the class name. That's just a proper naming convention. It's called upper camel case. So camel case typically, or lower camel case typically starts with a lower capitalization for the first word, but upper camel case, every word starts with a capitalized letter, even the first one. So
isn't spaceship one word?
Dominic, don't ever say that again. I don't know. It might be. I don't know. That's actually a very good question or good observation. It might be.
I think it's either way. I think both is correct.
Yeah, it could be. English is my second language, my friend. I'm still learning it. But yeah, it might be. I might just have to take English again. But all right, let's go ahead and continue. So we got our class spaceship here. we're going to, like everything else, we need an init method, our constructor. And our init method is going to take three things. One, it needs to have the image that we're going to use to create it. It's going to have an X coordinate and a Y coordinate. So we know where to place it when we create it. Now, I showed you guys on the space or the outer space image how you're able to save it to a data member and just pass it as an argument. We could definitely do that. We're going to do that here, right? So we say self dot spaceship surface. We'll call it surface for now. I guess it would make sense to call it image. We'll say image. Spaceship image. Because technically it's not a surface. So we'll say spaceship image. And what we're going to do is we're going to assign it the parameter of image by saying pygame dot image dot load, and it's going to take in the argument of image, right? It's the same thing that we use, the same command that we use when we loaded in our image here. So that way, when we instantiate our spaceship object, the argument it's going to take should be the image file path. And that's going to be passed in here. It's going to be loaded into this method, which will then assign it to this variable. Now, the next thing is we need to give our spaceship a rectangle. Who knows why?
Hitbox.
Hitbox, right? For those of you not familiar with hitboxes, right? In games, the players, the characters, whether it is an enemy, if you know your player itself, everything has a hitbox, right? That's how the computer is able to identify when two different things touch, or I guess collide, right? When your bullets in Call of Duty land on the enemy player, right? That bullet has a hitbox and the player has a hitbox, and it uses these rectangles, or I guess really boxes, to see when they touch. It compares their X and Y coordinates to see if they intersected. And when they intersected, that's how the computer knows when something has collided with another thing. So we're going to have to provide something very similar to that. And you have to call it this, because Pygame is going to have issues if you don't call it this. It's going to have to be called self.rect. It's going to be looking, I don't know why, it looks for this keyword rect. Trust me, I've done a lot of debugging and it wouldn't work unless I use rect. So I learned it the hard way. So self.rect. And the way that we're going to create a hitbox is by saying self.spaceship image. We're going to call the data member of the image. And we're going to give it a rectangle by saying .get rect for get rectangle. Right, this is going to give it a rectangle. Now, the next step is going to be how we want to, how do I say this? How I want to position the rectangle. There's not a good way of showing it. Let me see. Maybe we can check documentation. Let's go to rectangle, because I don't want to confuse you. Rect. Where's the get rect? Don't move, no. There are certain parameters that it takes. Is it this? Okay, I can't find it, but the best way I can explain it is we have to pass in how we want to be able to align our image, right? So when you give it the rectangle, you no longer grab the image and use the image to move it left, right, up, or down. You use the rectangle, right? So when you give the X or Y axis to the spaceship, it's going to give it to a specific part of your rectangle, right? So as you saw for the, this is your outer space image, right? When I aligned my outer space image to my screen, what did I use? What did I tell you it was using to align it?
Top left.
The top left corner, right? By default, it used the top left corner for it to align it to my surface. Well, when you give the rectangle to a image, you can set it to the top left by default, or what you can do is you can give it an optional parameter of where you want to use it to align it. What we're going to do is we're going to give it the mid bottom. We're going to specify that the mid bottom should be where the X and Y is going to be used to align it. And the reason for that is going to make it easier to align it to the bottom part of our screen, because our spaceship is going to be only the bottom, right? There's no reason why our spaceship needs to be at the very top. Because when we start, it should start at the very bottom of our screen. So it'll make it easier if I can control the mid bottom section of my spaceship to better move it left, right, up, or down, right? So I can set the mid bottom X and Y coordinate to the max of Y axis. And I will know that the bottom part of my spaceship is going to be at the very bottom part of my screen, and they'll be aligned. And then if I set the X axis to 250, or for example, 400, because our screen is 800 pixels left and right. If I set it to 400, I know my spaceship will be dead center. Does that make sense? So, if I say 400 for the X and 800 for my Y, it'll align it. Let's make this smaller. It'll quite literally align it here, right? Because it knows it's going to use this point right here to set it at 800 on the Y axis and 400 to the X axis. And I can guarantee my spaceship will be dead center at the very bottom of my screen. Does that make sense? So I'm trying to use that to orient my rectangle. So I'm going to say mid bottom is equal to the X and the Y axis. I could use top left, top right, top middle. I can even say middle if I wanted to, but I want to use the mid bottom part of my spaceship so I can use that to make sure it is properly formatted at the bottom of my screen. And now I'm also going to give it one more method, which is going to be a get method so I can grab its position. Why do you think it's important to know the position of my spaceship?
So you can update it.
Yeah, so I can update it. Also, I can use it to know where my bullet needs to be created, right? So every time I press a key to shoot a bullet, I probably want to know where my spaceship is at, so then I can make sure my bullet is near where it should be firing, right? So I need to know at all times where my spaceship is at. So I'm going to require some kind of get method to get the location of it. So I'm going to say define get position. And all it's going to do is return. And I'm going to put this in a tuple so I can get both the X and Y axis. Self.rect.x, comma, self.rect.y. Because this is going to have a tuple of the coordinates of where my spaceship will be at. So self.rect.x and self.rect.y will give me the coordinates of this rectangle. All right. Now, finally, we can go back to our main file. Let's save this. Go back to our main file. And at the very top, we're going to import our spaceship. From spaceship, import spaceship. Next, we're going to create our spaceship object. In our init method, just like we did in the other games we have, the moment that our init method runs, we should be able to instantiate our object because it needs to be ready to go the moment our game runs. So I'm going to say self.spaceship is equal to, and then I'm going to call the spaceship class, and we have to pass in the parameters that we set. The image has to be the file path. So I'm going to say, it has to be a string for the file path. It should be assets / and then the name of the spaceship. I know it's a weird spaceship name. I don't know why it's called that. It's dir with 3 R's spaceship.png. Usually when your image doesn't load, it's probably because you misspelled or you messed up the file path. Just be aware of that. And now, if you recall, I want my spaceship to be at the bottom of my screen, dead center. So I want to make sure that the x-axis, if it's in the center, it should be at 400, and the y-axis should be the very bottom of my screen, so it should be 800. Right, so my x-axis is going to be 400, comma, 800 for my y-axis. Now this creates the spaceship. It has an x and y axis, but it's yet to be put on my screen. We have to blit it, right? We have to blit it. Now, do I want to blit my spaceship on my screen or on my space surface?
Your
Space
space
surface.
servers?
I heard a bunch of
The
Space
space
surface.
surface.
space surface, yeah. Self.space surface dot blit. And I'm going to blit my self.spaceship. And where do I want to blit my spaceship at? At self.spaceship dot rect. And maybe it's not a good way of doing that. I guess we should do get position. Let's try get position. Get position. Yeah, we'll use get position because we already have a getter function for that, right? We shouldn't be accessing data members directly. So we'll use get position instead. Now, if we did this correctly, it should work. Let's give it a try. And I did it wrong. Argument 1 must be pygame.surface.surface. Why am I getting that? Is it because it's not called surface? It could not be that, right? No, it's not. Hold on. Pygame sometimes acts weird. Okay, it's not that. Argument 1 must be a surface, but it is though.
Do you think it's asking, because you're using self.spaceship, to grab the image of the spaceship, and maybe it's asking where you want it first, and then what you want on it.
I think actually it wants this. It wants the image. Let's do spaceship image. No, yeah, dot spaceship image. There's no way it's this, is it? I hate it so much. All right. Okay. It hates me. But all right. So here, I want you guys to pass in when you get the self.spaceship, grab the spaceship image. I guess very similar to how we did this the image for the outer space. We should be doing that as well here. We're grabbing the image of the spaceship, and then we're using the position to put it there. Which I guess makes sense. That's what we did earlier. We passed in the image. It didn't want the whole object. It wants an image file or surface. So we should have our spaceship dead center on the x-axis, and it should be at the very bottom of our y-axis at 800, right? Because we're controlling that mid-bottom part of our spaceship. Did everyone get to this point? Any confusion on anything we've done so far?
You go back to your spaceship pie?
Yeah.
Like I messed something up.
So I created my spaceship image, which is holding the image, which makes sense, I guess, that why we need to call this one. So we can get the image. Actually, let's change that. Let's go ahead and define get image. And let's return self.spaceship image. I don't want to deviate from the standard of using get methods to access the data members. So we're going to use this method instead, than calling the image data member directly, right? Because that's not how we do things. We're going to use get methods. Are you good, Dominic?
Sure.
I don't want to continue unless you're good.
I don't know
What's
what
going
it
on?
is. Something. I'm keep getting errors, but I don't
Show
see
us.
where.
Share screen real quick.
Oh, sure. Can you guys see my screen?
Yeah, so it doesn't understand where the image is at. Assets has an S at the end, so the file path, right here, when you're creating the file path for your asset, you forgot an S.
Oh, assets? Look
Yes,
at
sir.
you. Appreciate it.
Try it out before you stop sharing. There you go.
Go bango. Pickle mango.
All right. But yeah, since I changed the way that we grab the image, use the get method here as well. So you're not accessing the data member. All right. So we have our background, we have our image, but there's not a game yet, right? We want to make sure that we can move this character. So what we're going to do is we are going to give our character some functionality. Now, the way that we do that is by using the events, right? We have the fact that we have event in pygame.event.get. We're able to already grab events that are happening in our game, but we haven't actually implemented that into our program yet, right? So we're going to want to actually add that in here. So the way that we're going to do that is by coming to our for loop. And we are going to grab the keys that are being pressed. So every time that we loop through our for loop, we're going to do keys is equal to pygame.key.get pressed. Actually, get it out of your for loop. I don't think we need in the for loop. But this command should be able to give us what keys are being pressed. And just to see how that works, I'm going to go ahead and print keys. And it's going to be a lot of feedback here, I believe. So just be prepared for that. But as you see here, it's a bunch of false. It's it's a huge loop. It's an infinite loop. As you can see, it's a bunch of output here. Because it's constantly grabbing the status of every single key on my keyboard and I'm printing it out. And notice, I'm going to start pressing keys and you're going to see some output here change. If you see it moving, but you don't, because it's going too fast, you actually don't see the keys being pressed. Let me go ahead and scroll up after I close it to see if we can find some. Let's see. Tell me if you see anything say true. Oh Lord, so much. Oh, right here. True. So it's a lot of feedback because obviously it's taking all the keys in my keyboard and it's sending me their status, right? So it's a lot, right? So it took a while to scroll up, but here's one key that I was pressing when it checked at that exact moment. I don't see anyone else at this moment here either. But that was the first one I found. Here's true. Let's see if there's anyone else. Here's it again, true. So this runs very fast. It runs, I don't know how many times a second. It's checking all this stuff every single time this while loop is going. I'm grabbing the status of all the keys. I'm assigning them here and I'm printing out the status. And it's obviously showing me every single one. So we're going to use this command to our advantage. Every single time that our loop is running, we're checking the status of all our keys, which is going to allow us to see if any key is being pressed. So I'm going to say if keys, and it works as a dictionary, right? There's some specific keys to grab the one that you're looking for. And I'll show you where this comes from. Keys, let's go with keys. Pygame key.get press. Get the state of all keyboard buttons. So in here it is. Here's the table that shows you what keys are represented by what keywords. The ones that we care about is going to be the WASD keys. Or if you want to do the arrow keys, you can if you want, if you're a weirdo. But if you're cool, you're going to use the WASD keys, right? So I'm going to look from real quick. If you want the arrows, if you're that guy, you can. And that's going to be the commands right here. These are the keys for it. K underscore up, K underscore down, K underscore right, and K underscore left. This is the key value pair, or the key that you're looking for. The value is the key itself. The key is going to be this string right here, right? Or it's actually not a string. It's going to be, we're not going to put it in a string format. We're just going to go ahead and type this out. So if you want to use the arrows, you can use this. We're going to use the WASD. And it should be as simple as K underscore and then the number or the letter of the key. We're going to use the A, the S, the D, and the W. Right? So with that in mind, I'm gonna say if keys, and I'm gonna say pygame dot k underscore a, and that'll give me the a. I'm gonna put pass for now. I'm gonna say if keys pygame dot k for d. This would be my rights. I'm gonna put pass for now. If keys pygame dot k, we're gonna get the w for up. We'll put pass. If keys pygame dot k s, put pass. Let's remove this print keys. So we're gonna check the status for these. Right, this is checking if the status of the key at k underscore a is true, then we're gonna do one thing or another. And we're doing the same thing for all the other ones, the D, the W, and the S. This is checking the true or false statement for this specific one. And just to show you how this works, I'm gonna go ahead and print I am pressing the A button. And just run this again. Here's my window. And as I hold it, you see that it prints out I am pressing the A button. So every single time I press this key, I'm able to do something because I'm able to listen to this key, right? And that's exactly what I'm looking for. That way I can be able to manipulate my spaceship. Now, with this check here in our while loop, we can go back to our spaceship and actually add a method to our spaceship to manipulate the X and Y axis depending on the key that's being pressed, right? So we're going to go back to our spaceship and we're going to define a new method, and it's going to be called move. This method should have an argument called direction. Now, this is going to be your first little try it out on yourself assignment that you'll get for this exercise. You know how to grab the X and the Y axis already. Quite literally, the same way to update them is by grabbing them and either increasing or decreasing, right? They're variables, they're integers. So if you want to update the X or the Y axis, you can do it as such. You can do plus equals, or you can just reassign it a new X or a new Y by calling the rect Y or rect X. Right? I want you guys to come back to this. And then if you're pressing the A button, I want you to be able to call the spaceship object and invoke the dot move method that spaceship has here. So you should be able to say self.spaceship.move. Right? You're going to pass in a direction, and depending on what direction it's taking, you're going to do one thing or another. Right? You're going to do that for the A, the D, the W, and the S. You don't need to know any crazy Pygame code for this. You already have it set up here. You already have the method. It's just filling in the code for the method to get it to move. We'll take 10 minutes on this. All right, time is 8:31. Let's go ahead and come back at 8:41 to get this done. Additionally, your spaceship should not be able to leave your screen. So once it gets to a certain point, from the left to the right, it needs to stop. Also, you should not move below your screen, and you should not move above your screen. Give that a try. My kids finally stopped yelling, but there we go. So when fixing the direction of the spaceship, we don't want to make sure, well, we want to make sure that our spaceship isn't able to come all the way to the top and shoot our aliens. So we're going to set a restriction to how far up our spaceship goes. So I'm going to say if self.rect.y is greater or equal to, let's go with 250. And now that's about 2/3 of the way up. Pretty good. That's about right of where I want my spaceship to go. Right. Once it reaches 250 on the y-axis, I should not be able to decrease my y-axis to go any further. And just for the people at home, I'm gonna reiterate, so bear with me, guys. But to move the spaceship, we're going to pass in a string into our move method every time that we press a key. If we press the A key, then we're going to pass in the string A. If we press the D key, we'll pass in the string D, and so on and so forth. And depending on the string that's being passed into our move method, is going to dictate what direction we'll move. If we're moving with the A, which means to the left, then we're going to want to decrease our x-axis on our rectangle by 5 to get it to move. But we also want to set a limit to when we're going to move our axis, right? This limit is going to keep our spaceship from going past a certain border of our window, right? So you kind of want to mess around with your the limits, but this seems to be the sweet spot for the restrictions to ensure that our spaceship stays within a left and right limit, which is the screen. Our spaceship can no longer go past our screen, and we cannot go too far up. And that should take care of our move method. Do I have any questions on how the move method works for you guys here? Or anything that we did? Okay. Well, I'm gonna start with the bullet class, but we might have to stop halfway because of time, or should we just stop here? What do you guys think?
Mm. I do have one question.
Sure.
So when you're building all these different classes, what would make you want to build the functionality into one definition versus another? Like what makes you want to put like the actual code in one spot versus another? Like for like this, you put all of the if statements into the spaceship, but none into the main function other than passing in.
Responsibilities, right? So that's a great question, Daniel. Thank you for asking that. Yeah, so when thinking about the structure of your program, you want to think about what object or really what class should be sharing this responsibility. Does this responsibility fall in on? Should the entire game be handling the positioning of the spaceship, or should the position of the spaceship depend on the spaceship itself? Right. So that's really where you start weighing your options. Like, do I really want my entire game to be the one who dictates how my spaceship moves? No, it really starts making more sense that maybe my spaceship should really be the one who takes care of how it moves. Right. So that's really where I came to the conclusion because I'm the one that I created this time. This is not like a copy and paste. You
Mhm.
could probably find like replicas of this game somewhere else, but this code I was the one that created it. I, I I thought it was better to really give the move function to the spaceship to handle it here, right? I didn't think it made sense to be moving my spaceship out here every single time I have this loop iterating, right? It's just less code for my game to have to manage with. Um, I'll just give it to my spaceship as it is, right? Also, you have to think about reusability. You know, if you want to create another spaceship object as well, the spaceship object should be able to manage the move functionality. Because if you had, let's say, now this is thinking more bigger scale, but think about a massive multiplayer online game, an MMO, right? Should the game be handling everyone's positioning, or would it be easier to keep the positioning and the movement isolated within each player? That way, you just call on the player and tell it to move, right? Then handling this code all within the main program. Um, so it makes more sense to put it here. Same thing with get positioning, get image. My main function should not be the one doing that. I shouldn't be manipulating directly the data members. Uh, a method should be able to hand that to me. Does that make sense?
It does.
All right. Well, we're gonna stop it here, only because I don't want to start the bullet class because the bullet class is it's just as in depth as the spaceship one was. It's gonna take some time to do it. But I know that some of you guys probably gonna want to adventure and kind of continue doing those on your own. You guys can just know that I'm gonna do it anyways the next day. So if you want to go over the same thing that you're gonna do anyways on your own, then so be it. But I will continue doing this. We should be able to finish the entire program tomorrow, and then I can leave you with some assignments that you can try on the weekend to continue adding to the game if you like. It'll give you something to work on. But we will continue picking off from where we left off today. We'll pick it up tomorrow, right? And we'll stop that here. I do apologize for my screaming child in the background from earlier. We go ahead and stop the recording now.